All right, so what I'd like to do in this video is show you how you could calculate a confidence interval for the population mean using JUMP. I'm going to show you this two different ways. First, I'm going to show you a scenario where we have the summarized statistics, and then I'll show you a scenario where we have the raw data. All right, so in the Week 5 learning module, I put up 3 PDFs. And one, they're for each of the 3 types of confidence intervals. And now this is all review, to be honest with you, from Statistics 1. This is confidence intervals for the population mean and population proportion. But this is on a single sample of data. So if you remember from Statistics 1, there are 2 different probability distributions that we use for our sampling distribution. And one's the normal distribution with z-scores, and the other is the t-distribution, and we use t-scores there. So what I want to do is show you how to find a confidence interval for the population mean using the normal distribution right now. So you could open up that PDF. I've already done it, and it's the first PDF in Week 5. And, after all the notes, when you scroll through the notes, towards the end, there's an example with summarized statistics, and it's worked by hand, as you can see, and the solution here is in red. And this is something that, again, you would have done in Statistics 1. So my point right now is just to review the topic, refresh your memory on what you did back in Statistics 1, and also show you how to do this, not using the defining formulas, but to show you how to do this in JUMP. All right, so let's give a look here. So it says, the Burger King Corp claims that the average weight for its pre-cooked burgers is 1/4 pound. All right, with a population standard deviation of 0.03. All right, so they're claiming they know the parameters. In other words, if we describe the whole population, their center is 0.25 and the spread is 0.03. All right, so the FDA is skeptical of this claim due to an increase in the number of complaints regarding the weight of the burgers. The FDA goes to a region, takes a sample of 100 hamburgers. The average weight of the sample, now that's an X bar, is 0.248. All right, so notice that the mean of those 100 burgers is not exactly 1/4 pound. Instead, it's 0.248 of a pound. All right, so letter A. To set up a confidence interval, what distribution will you be using and why? All right, well, if you remember from Statistics 1, if you are given the population standard deviation, which we are, right? It says here, population standard deviation. That means we use the normal distribution and z-scores. Now, if you're given the sample standard deviation, S, then we would be using the t-distribution. All right, so letter A. We'll use the normal distribution and z-scores since the population standard deviation is given to us. If it were unknown, then we would use the t-distribution. All right. So that I said this concept is seen in the next section as well. All right, so letter B says set up the 95% confidence interval. So now if you remember a confidence interval, what it entails, it's really a 2-step process. You find the error, which is just a formula. It's a z-score times sigma over radical n. And remember this sigma over radical n, this portion of the error formula, that is called the standard error of the mean. So this is a critical z-score times sigma divided by radical n. And it's a pretty simple calculation. And then you take that error once you have it, and you add it and subtract it to the sample mean. So the actual confidence interval, remember, is found by taking the sample mean and adding and subtracting the error. What this does is it opens a window of opportunity that you feel comfortable stating that this confidence interval lies within. Now, there's lots of interpretations of this, and what we're going to do in the next couple of videos is talk about, how most people say this idea and this concept, but, the reality of what it actually means. So you'll notice that in the next video or two, where we really dive into what's the meaning of a confidence interval. All right, so let's talk about how to get this confidence interval. You can see I worked the numbers here with the defining formulas, and at the end of the day, I got about 0.242 and 0.254, once I rounded. So once you round these values, this is what we got for the confidence interval. That's somewhere in there. How do you do this in JUMP? So if I go to JUMP, in the add-ins menu, I had you install a couple of add-ins, and one was teaching modules. Remember, we use that a lot. The teaching modules, there was this distribution calculator, which was a really nice tool. In the statistical calculators menu, there's a confidence interval for one mean, a confidence interval for proportions, and there's several others that we're going to be using later in the course. But the first thing I want right here is what we just calculated, which is a confidence interval for one mean. So I'm going to click that. All right, so the very first thing it wants to know is it's asking you, hey, what are you going to give me right now? That's what JUMP is asking you. Are you giving me raw data, or do you have the summary statistics? Now, obviously, we have the summary statistics here. In other words, what? Well, we know that the population standard deviation sigma is 0.03. We also have our sample, that's n of 100 hamburgers, and as you can see, we also here have the sample mean. The sample mean is 0.248 of a pound. All right, so in other words, we have the summary statistics. So I'm going to tell JUMP, I've got the summary statistics, and say OK. All right, so it opens up a window. The window's really kind of self-explanatory. First thing it picks your brain on is, what kind of confidence interval are we going to be doing here? We're going to be calculating a confidence interval based on the normal distribution and use z-scores, or are we going to do a confidence interval based on the t-distribution? Now, we've already established, since we're given the population standard deviation, we're going to use the normal distribution. Remember, if we were given the sample standard deviation, which is an estimate of the population standard deviation, we would be using the t-distribution with n-1 degrees of freedom. So for this example, we are using z-scores. All right, so I'm going to leave Z checked. All right, sample average. All right, well, we know that. That is 0.248. That was given to us in the question. That's the sample mean. The population standard deviation, again, given to us, 0.03. And then the size of the sample is 100. All right, so the next thing it wants to know is, what kind of a confidence interval do you need? Do you want a 95%, 99%? In other words, what's going on here? Well, if we go back to the question, you'll see the question here says, set up a 95% confidence interval. All right, so I'll just go right over here, and that's the default, as you can see, 95%. And, if you click somewhere else in the menu, it automatically calculates the confidence interval for you. So now, if you remember, when I did this by hand, the confidence interval I got is right here. This is the actual confidence interval, 0.242 to 0.254 pounds. As you can see, JUMP gets you the same two results here, right? 0.24212, 0.25388. When you round those, you get those values that you see there. Now, a couple things that JUMP also gives you, which is kind of neat. The first thing it gives you is what they call the Z multiplier, which is 1.95996. Now, that number should look familiar because that is the critical z-score right here, this value, which is z sub c for a two-tailed scenario using the normal distribution. It's a famous z-score for 95% with two tails. We usually approximate it to 1.96. As you can see, JUMP writes it as 1.95996. All right, another interesting thing it does, the standard error of the mean, which is 0.003. Now, what is that? Well, that's this other part right here. So this part of the error formula, this is called the standard error. Sorry, the S's don't come out so good on this. I'm writing on a PDF, and you can see how weird it looks. It's kind of choppy when I use the when I write directly on a PDF. All right, so that 0.03 divided by radical 100. In other words, sigma divided by radical n. Remember, that's called the standard error of the mean. So 0.03 divided by the square root of 100. Oops. So there it is, 0.03 divided by radical 100, 0.003. So you can see JUMP crunches that for you. So this is what JUMP does. It takes the Z multiplier, multiplies it with the standard error, takes that result, which we already know, by the way. I have it. We worked it out. Here it is, 0.00588. It takes that number and adds it and subtracts it to the 0.248. So that's what's going on here. It takes the product of these two things, the z multiplier and the standard error, and then it adds and subtracts that error to this 0.248, and that's what opens up this interval. And then, of course, it shows you, here's the interval. So this blue line right here, that represents the 0.248 plus the error, which gets you to this 0.25388 number. Subtract the error, which gets you backwards over here to this 0.24212 number. All right, so there you have it on how to calculate a confidence interval for the population mean using the normal distribution in JUMP when you have summary statistics. All right, so look out for the next video on how to do a similar concept using raw data. If you have any questions, shoot me an email. I'd be happy to help you out. Thanks for watching.